Alright, we're moving on to page 17. And on page 17, if you look at example number 1 here, we're now being asked how many grams of iron metal are needed to react completely with 23.5 grams of oxygen gas. This is a problem where we're doing grams of one chemical and grams of the other chemical. You guys, if you're doing a problem that is grams and grams of each chemical, guess what? You're going to need, dun dun dun, 4 fractions. Oh my goodness, 4 fractions. Whatever will we do? Well, let me tell you right now, you're going to want to start your 4 fractions all the way to the left, or you're going to run out of space. Okay, like really, start them against the edge of your paper on the left, or you will not have enough space to finish the problem. I guarantee it. Start them all the way over on the edge. Please, just trust me. Okay. So that's the first thing. Next, if we look at this problem, 23.5 grams of oxygen gas. Oxygen gas is this O2 right here. So that's where my bridge is going to start for this problem. They're asking me about grams of iron, so I'm going to point my bridge over at iron. This is my bridge for problem 1. The number they gave me, the given, 23.5 grams of O2 goes over 1 at the beginning of my problem. I know that what goes up must come down, so grams of O2 will move down to the bottom as well. I cannot get on my bridge yet, because this bridge is a number of moles. And I don't have moles of O2, I have grams of O2. So before I can get on the bridge, I need to end up with moles of O2. I don't have them yet, so I'm going to have to turn this into moles first before I can do anything else. Now, if I have a fraction that is moles and grams together, this is the kind of fraction where we do it the old way, where we do use 1 for our number of moles, and our grams come from the periodic table. If you look at the periodic table, there are the mass of oxygen is 16. There are 2 oxygens here, so you do need to multiply it by 2, and that's going to get you 32.00 grams of oxygen. Then we do what goes up must come down, so moles of O2 will also move to the bottom. Now, once you have moles of something on the bottom, now you can start your bridge. So I'm going to use 3 moles of O2 from the start of my bridge. If I cross my bridge in the reaction, it's telling me to end with 4 iron. So 4 iron, but not just 4 iron. This is specifically, remember these coefficients tell us moles. This is 4 moles of iron. You'll notice I've used grams of oxygen twice, can't use that again. Moles of oxygen twice, can't use that again. Moles of iron has only been used once so far. And if I remember that what goes up must come down, moles of iron will be on the bottom of my next fraction. Now I've already crossed the bridge, don't go back over it, okay? We've already crossed it, we don't want to go back. We've used moles of iron twice though, and we've used moles of oxygen twice. We can't use any more moles. The only thing that's left is to actually answer the question, how many grams of iron? So I'm going to put grams of iron on top here. And again, when we have a fraction that is grams and moles together, this is like our old school fractions where we used 1 for our number of moles every time, and our number of grams comes from the periodic table. If you check iron on the periodic table, its mass is 55.85. From here, you do need to put it in your calculator. Remember, everything on top gets multiplied, so you can type 23.5 times 4 times 55.85. Everything on the bottom gets divided, so you can type divided by 32 divided by 3. You can do that all in one line on your calculator. You don't have to like stop and press enter every so often. You can do it all in a row. If you type it correctly, you should get 54 point, and it should round to 69 grams of iron. Nice. Let's look at number 2. Number 2, how many grams of iron 3 oxide will be synthesized if you start with 19.8 grams of iron metal? Again, we're looking at grams and grams. This is a 4-fraction problem. Again, you want to start your 4 fractions all the way over to the left, or you're not going to have enough space. 19.8 grams of iron metal are the given, so 19.8 grams of iron over 1 is going to be my first fraction, and iron is where my bridge is going to start for problem 2. There's the start of my bridge for number 2. The problem 2 is asking for grams of iron 3 oxide. That's this compound over here, so that's where my bridge is going to point. I remember that what goes up must come down, so grams of iron will come down to the bottom. I cannot get on the mole bridge yet. The mole bridge is a toll bridge, and I cannot pay the toll if I do not have a mole. Okay, the toll has to be in moles. So right now, I don't have moles of iron, I have grams of iron. I cannot get on the bridge yet. I need to make moles of iron so that later I will be able to get on the bridge. So, again, if you have moles and grams in the same fraction, the number of moles is going to be 1. Grams will come from the periodic table. As we looked it up earlier, grams of iron from the periodic table is 55.85. I know that what goes up must come down, so moles of iron will come down to the bottom here. And oh, now I have moles on the bottom. This is where I get to use my bridge. How many moles of iron is going to come from my bridge? I go look at my bridge. The bridge is using 4 moles of iron. If I cross my bridge, follow it across, it's pointing at 2 Fe2O3. But 2 what of Fe2O3? Again, remember these coefficients are always moles. Next, I have to do what goes up must come down. So moles of Fe2O3 will move to the bottom. And I know that if you check, you've used grams of iron twice, you've used moles of iron twice, you've used moles of Fe2O3 twice, can't use any of those again. We gotta switch to the only thing left, which is what they're asking me for. Whatever they're asking for always goes on top of your last fraction. Grams of iron 3 oxide, Fe2O3. Again, when you have a fraction that is grams and moles together in the same fraction, this is going to be just like our old unit where our number of moles is 1, our number of grams is from the periodic table. For Fe2O3, we're going to need, I'll come down here and do it, 2 irons from the periodic table, 3 oxygens from the periodic table. Iron is 55.85, oxygen is 16. If you add that up, you get 159.7 as your number of grams. And of course from here now we just need to put it in our calculator. Remember, anything on top you multiply, so you can type 19.8 times 2 times 159.7. You don't have to include the ones, right? Multiplying by 1 doesn't change anything. And anything on bottom you divide, so divided by 55.85 and divided by 4. You can type all those things in one line in your calculator. You don't have to press enter every time. If you type it correctly, then when you finish, you're going to get 28 point, it rounds to 31 grams of Fe2O3. Okay, before you move on to your stamp, which is going to include finishing this page yourself, there are other things to do for your stamp as well, but finishing this page yourself is part of it. Yeah, make sure that you notice that this reaction is not balanced. You're going to need to balance this reaction before you can do it. You don't know what numbers are in here, so you don't know what numbers to use on your bridge. So you're going to have to balance this like we did back in Unit 7. I'll even give you a head start, reminding you that there's 1 copper on the left and 3 on the right, 2 nitrogens on the left and 1 on the right, and from there you're going to have to figure out how to fix it. Good luck.